Okay, ladies, this is problem number 19 from page 23, which is section 1.4, where we're finding quotients. And you remember that a quotient is the solution to a division problem. And something that I failed to do, and I'm looking for the marker cap, by not doing this second video, this is another example of something that is strange when you're doing long division. We have the problem 9x to the fourth plus 3x squared minus 12 that you're going to divide by the binomial x minus 4. But we have to put in placeholders here. For example, if I asked you to divide 120 by 4, you know that 3 times 4 is 12. You have to bring down to 0. 4 goes into 0 0 times. And you have an answer of 30 for that. But let's say that you were dividing 10,020. This tells us that you have 1 times 10,000, 0 times 1,000, 0 times 100, 2 times 10, 0 times 20. And if we don't have those place value zeros in there, it would look like that, wouldn't it? We just have the 1 and the 12. Well, obviously to us, very, very obviously to us, 12 is way different than 10,020. So it's this principle right here where if I just say, well, we're going to use non-zero digits of 1 and 2, up here in this problem it also has non-zero digits, just 1 and 2, because all of the other digits in here are 0. But there's a huge difference, obviously, between those two numbers. They're not the same. So you have to use those 0 digits as place value holders. And that's what you're doing up here with the 9x to the fourth plus 3x squared minus 12. When you do long division, you want to use the same principle. So we've started to, we have x to the fourth, and we have x squared, and then we have a negative 12. So when you're doing long division, you have to be counting down sequentially with the powers of your exponents, just like you're counting down to 10, 9, 8, 7, 6, 5, 4, 3, 2, blast off. So every place that you're missing a power, you're going to say 0 times x cubed, because 0 times anything is 0. Is that making sense so far, Rich? So what we have is going to use the same principle. 9x to the fourth divided by x, it's going to be 9x cubed. 9x cubed times x, 9x to the, whoa, I'm not sure what that's supposed to be. 9x to the fourth. Now we have 9 times a negative 4 is negative 36x cubed. And this is where, see, Rachel was trying to do this problem. Oh, look at Miss Doreen, she's got her engineer's outfit on. This is where, if Rachel had gotten this far in her problem, I don't know if she did or not, but this is where it's like, how can I subtract negative 36x cubed from 3x squared? And she just said, yep, that's how far she got. She thought, there's something wrong. And that's because I had not reminded you guys or taught Rachel that you have to have the exponential holders here. Now it makes a whole lot more sense. We're going to subtract this. So we have 0 minus a negative. We now have 36x cubed. Going to bring down positive 3x squared. X goes into 36x cubed plus 36x squared times x, 36x cubed, 36 times, oh good grief, this is a mess. 36 times a negative 4, 36 times 4 is 144. So now we have a negative 144 x squared. live through this whole thing. Subtract 3 minus a negative 100. Don't forget to put your square there. See how I forgot that? You have negative 147 x squared.
It's not a negative.
Thank you, Rachel. Minus a negative is positive. Bring down the 0. What that looks like. Plus 0x. Now, x goes into 147x squared as minus 147x.
Why is it minus?
Because I was calling it minus from before. I'm having a hard time with that plus. Rachel said it's not minus because it's 3 minus a negative, which becomes 3 plus 144, which is 147x squared. X goes into 147x squared, 147x. Multiply that out. You have 147x squared minus 4 times 147 times
Ouch.
4, 8, 16, 17, 18, and it's possible that my remainder is going to be just all messed up royally. 4 and 5, is that right, Rachel? No, yeah, that's going to be right. 588 minus
Yeah.
588x. Now we're going to subtract this. 0 minus a negative. 588x. Bring down. Minus 12. This is rather a lengthy, nasty old problem, isn't it? And it is divided by x minus 4, Rachel?
Mm-hmm.
For sure?
I'm positive.
Okay. X goes into 588x. 588 times. 588x times 4. And I'm perfectly fine with you guys using your calculators. 4 8s are 32. Carry 3 is 35. 3. Hopefully 2352. But it's a negative. Negative 2352. Subtract. So that's going to be a negative 2340 minus 2340 over x minus 4 or a remainder of a negative 2340. Let me do this as a remainder. Negative 2340. Drum roll. I sure hope this is an even numbered problem, Rach.
It's an odd number.
On page 23. I meant odd. Chapter 1, section 1.4. Yes! Except I said negative. Negative 12 minus a negative, that becomes a positive. Not the negative. Remember what I've been saying about negative signs messing you up? Problem number 19. The solution is 9x cubed plus 36x squared plus 147x plus 588 remainder 2,340. Yes, God is good. Okay, look at this. This is what you do when you're missing powers. You want them to go in descending order without skipping anything. Thanks, Rachel.